Okay, so while we wait for the whole class to join, we can start P4 question. The one which we left yesterday, we will discuss then when everyone is joined. So now, if you have any questions so far, you can ask. Any problems, you can ask. Okay. So let's start with P4 probability questions today. There are 6 cards. Write the probability that the card is 5 or 6. There are 2 cards, two out of 6. Okay, 1 out of 3. Then Suleika does this 300 times. How many times expect 5 or 6? So we did that before. You can just do 300 times 1 by 3. So 100 times you can expect 5 or 6 to card to show up. Okay, so far I think it's easy, no questions. Suleika takes 2 cards without replacement. So this is the keyword. Make sure you understand without replacement. Okay. No, it isn't. So find the probability that the sum of the numbers on the 2 card is 5. All right. So what are the 2 cards that we can pick so that we get the sum of 5? So either you can pick 1 and 4, or you can pick 2 and 3. Is there any other possibility? 1, 4, 2, 3? No, right? So these are the 2 probabilities. Now we need to find them. Each card is 6 times. So what's the probability of getting a 1? Or first one being 1 by 6, and the second one being 4, 1 by 5. Because note down that one card has been taken out. It has not been replaced. So you decrease. Okay. And now this bracket you need to multiply by 2 because the order can change. It can either be 1 and 4 or 4 and 1. Right? So you have to multiply with 2. Okay. Or means add. Now similarly, this is 1 by 6 multiply by 1 by 5. Okay. And you need to multiply by 2 because the order can change. So another probability needs to be added. Okay. 2 over 30 plus 2 over 30. So that is 4 over 30, right? Any questions you can ask? Next, find the probability that at least one of the numbers on the card is a square number. Okay. At least one of the number of the card is a square number. What are the square numbers here? There is 1 and there is 4, right? No other square number. So out of these 2 cards at random, we want either 1 or 4. One of them being 1 and one of them being 4. So that means either we can pick, or let's say elimination. Let's say we don't pick 1 or 4. Okay, 1 minus probability of not 1 or 4. Let's try like that because that will be shorter. You can eliminate. Okay, 1 minus the probability of not being 1 or 4. Okay, let's try that. So that means the first number can be 2, then second one can be 3, or first one can be 2, second one can be 5. Like make different combinations. First one can be 3, second one can be 6. Is there any other combination excluding 1 and 4? We don't want 1 and 4 here. Okay, so that's it. 5, we didn't consider 5 and 6. So there is another one, 5 and 6. Okay, 4, 5 and 6. Correct? Okay, so let's now find the probability of these. Probability of being 1 and 2 or 3. Okay, without replacement. So 1 by 6 multiply by 1 by 5 multiply by 2. Okay. Similarly, for everything, all the remaining numbers is the same probability. This plus another this plus another this, another this. So rather than saying 2, how many brackets are here? 1, 2, 3, 4. Okay. 4 twos are 8. We can just multiply with 8. Okay. Let's do that. So that will be 8 over 60, 30. So 1 minus probability of not being 1 and 4. That means that will be 1 minus 8 over 30. Okay. 1 minus 8 over 30 is 22 over 30. So let's revise the question one more time. There are, because new students just joined, there are 6 cards, 1, 2, 3, 4, 5, 6. Flicker takes 2 cards at random without replacement. Part 2. Find the probability that at least one of the numbers on the card is a square number. Okay, so that means we excluded 1 or 4. I made it like 1 minus the probability of not 1 or 4. So I'm not going to include 1 or 4. Okay, so that means either 2 or 3 we can take, or 2 or 5, or 3 or 6, or 5 or 6. Okay, and the probability of first one being 2 is 1 over 6 because it's one card with the number 2, and the second one of being 3 is 1 over 5 because without replacement the one card has been reduced from the denominator. Okay, similarly all other brackets have the same probabilities. Why we multiply with 2 each bracket? Because the order can change, right? That's why we multiply with 2. The first one can be 3, second one can be 2. That's why you multiply with 2. 8 over 30 and 1 minus. So this is the probability of getting 1 or 4. Okay, any questions, any doubt, please ask. So now I guess like all the students are have joined who want to join today. So this question from the yesterday one, it was tricky, and so let's finish that. Some students didn't continue in the extra class, extra 10 minutes. So Mary picks a ball without replacement from the 12 balls. Okay, what are the 12 balls? You can look at again at the question. A bag contains 5 red balls, 4 blue balls, 3 green balls. Okay, total are 12 balls. When she picks a green ball, she stops. Okay, the probability that she picks a green ball on nth pick is 21 over 220. Find the value of n. So how many picks we are going to do until we get the green ball so that the probability is 21 over 220. So first of all I did, we found the probability of green. What's the probability of green? There are 3 green balls. You can see here, there are 3 green balls, right? There are 3 green balls, 3 out of 12, or 1 out of 4 is the probability of getting a green. Okay. And what is the probability of not getting a green? Obviously, 1 minus 3 over 12. So that is 9 over 12. Okay. So then it's trial and error. Okay. Suppose, suppose you want, let's say you 3 picks. Let's say the first one was not green, second one also not green, but the third one was green. So how will you calculate this probability? First one not green, 9 over 12. Second one also not green, well, one has been picked out already. Okay, so that will come 8 over 11 because of color not green, one has been reduced in the next pick. And now comes the green. Third one is going to be green, so that is 3 over. How many are left? 10. Okay, because from the 12, 2 have already been left. So this is equal to 216 over 12 multiplied by 11 multiplied by 10, 1320. So that's not matching this one. Okay, so that's why then we tried 4 picks and ultimately we tried 5 picks. N is equal to 1, n is equal to 2, n is equal to 3, n is equal to 4, n is equal to 5. When we tried by trial and error 5 picks, we got the right answer. First one being not green, 9 over 12. Second one not green, 8 over 11. So one has been reduced, then 7 over 10, then 6 over 9. And then comes the green part, which is 3 over 8. Why 3 over 8? You are not using 3 over 12, 3 over 8 because it's without replacement. So already balls have 4 balls and be taken out. Okay, and that turned out to be exactly 21 over 12. So that's why it's the fifth pick, which will give you 21 over 20. That's a tricky and important part. Any question you can ask? Okay, this question is finished. We need to do one more P2 question. That's tree diagram. I wanted to do that. This one. You can read the question, start in 30 seconds. The tree diagram shows the probability of team winning or losing. Find the probability that soccer teams win at least one of the two matches. If they say at least one, that means either first one win, second one lose, or first one win, second one also win, or first one lose, second one win. Right? These are the three possibilities. So that these all have at least one win. Okay. So what's the probability of win and lose? Win and lose. Like you are going here, this path. So you need to, when you're going to the same path, you need to multiply the probabilities. So it's 1 by 3 multiplied by 1 by 4, right? Okay. Then or means plus win-win. Win-win, you need to go up. Okay. So 1 by 3 times 3 by 4. And then lose win. All right. So that is 2 by 3 times 3 by 4. Okay. So we have an answer. Let's just see if you get the same. Easy question. 1 by 12 plus 3 by 12 plus 6 by 12. 6, 7, 8, 9. So that is 9 over 12 total, which is equal to not 5 over 6. How is it 5 over 6? Oh, sorry. It's 10 over 12. Yes, 10 over 12 will be 5 over 6. Okay. If you want to simplify, 5 over 6. Okay, well done. Thank
Can't
you.
we also subtract from one, take the probability for lose, and then subtract from one?
Exactly. That's the smarter method actually. We should do that also. I was going to say that as an alternate method. The alternate method will be at least one means alternate is 1 minus no win. Okay, or lose. 1 minus no win. Because 1 has to be the total probability. So what's the no win probability means lose lose. So lose lose is this one. 2 by 3 times 1 by 4. Okay. 2 by 3 times 1 by 4. So that is 1 minus 2 by 12. So again 10 by 12. Okay. So same answer we get. So this is through elimination. And this is preferred. Like if you can think like that, that is preferred because save time. All right, we have another last question of the P2. We have done one P4 today. This is a little interesting, so that's why we should do this. Bag A and bag B is contain red and yellow sweets. Okay, let's draw them. Okay, bag A, bag B, red and yellow, red and yellow. Anna picks a sweet from bag A, Pam picks a from bag B. So the Anna picks a red sweet is probability of red is 2 by 5, and both Anna pick both Anna probability Anna and Ben both pick a yellow sweet. Okay. So probability of yellow and another yellow is 1 over 10. Find the probability that they both pick red sweet. Okay. Find the probability of red and red. Okay. Mhm. Think about it, how to do it. Okay. So if the probability here that red is 2 by 5, then automatically the probability of yellow will become 1 minus 2 by 5, so 3 by 5, right? Okay. And let's say the probability of bag in bag red is x. Then what about y? The probability of y, that will be 1 minus x. So these are the probabilities values, x, 1 minus x. I think we can now use them to solve the question. This 1 by 10, what's the probability of first being yellow, bag A being yellow? That is 2 by 5. Okay. And what's the probability of bag B being yellow? That is 1 minus x, right? And that is equal to 1 by 10 given. So let's solve this equation. So x is equal to 1 minus 1 by 4. X is equal to 3 by 4. So now we have the probabilities in the bag B also. Okay. So this is 3 by 4. Okay, never mind. Now let's find the probability of red. First being red is 2 by 5, and second being red is the x value, which is 3 by 4. Okay, interesting question. I think it's very good for the topic. 3 twos are 6 over 5 fours are 20. Okay, if you have any question, you can ask. We'll start in 1 minute. The next one you can ask. You can check the question meanwhile. Just a second. The answer is 1 over 3, so I need an 18 in the denominator. So just let me check one time. Please wait. Yeah, I made a. Okay, no, wait. Red is 2 by 5. Yellow is 2 by 5. Yeah, I made a mistake. You can see here that uh, The probability of yellow was 3 by 5, but I wrote as 2 by 5, okay, by mistake. So let's edit that. Yellow is 3 by 5. So 1 minus x, this will be 3. This will become 3. 5, 2, 6. This will become 6. 1 minus 1 by 6. So this is 5 by 6. Okay. 1 minus 1 by 6. X is equal to 5 by 6. And then first being grade 3 by 5. Second being grade is 5 by 6. Okay, good. It is 3 by 6. Now please wait a while. Meanwhile, I can attach the file. I think already is there.
The answer is 3/6.
No, it's 1 over 3. We are not getting 1 over 3.
Oh, I got 1/4.
We need 1 over 3. Uh, that way, 2 over 5. Red is 2 over 5. 3 over 5. What did I use? It is 1 over 10. Okay, that's sweet. First one being yellow. 3 over 5. Second one being yellow. 1 minus x. 5. X. 1 minus x is equal to third is. Yeah, here also I made a mistake. This first being red is 2 by 5, and second being red will be 5 by 6. So 5 twos are 10, over 6 fives are 30. So that is equal to 1 over 3. Okay, sorry about the delay. Clear? Any question you can ask? Let's do another now P4 question. Shop gives each 1,000 people a voucher, 28 use their voucher. The shop now gives each of us a voucher. Okay. Calculate how many of these are expected to use their voucher. So the probability will remain the same, right? Okay. So first of all, what's the probability of using voucher? 28 over 1,000. Maybe the voucher is not good. Okay. In decimal, you can write 1, 2, 3, 0.028. Okay. So now the probability of out of 1650, you just need to multiply with the probability 0.028. Okay, 1650. Okay, 462. It's double zero here. 462. Okay, well done, Hadia. Any question, anyone? You can ask. 15 students wear hats. 7 wear red hats. Okay, 7 are red. 6 are green. 2 are white. You can also write like that. 7 red, 6 green, 2 white. One of these students is picked at random. Find the ability that is with a red hat. How easy it is. It's just 7 over 15, right? Okay, probability of red. Two of the students are picked at random, so that the ability that these two wear hats of the same color is this. So now what they are asking, either first one is red, the second is also red, or first one is green, second is also green, or first one is white, second is also white. Easy, right? Can you try that, please? Discuss into 1 minute. Okay, let's start now. What's the value of first being red? 7 over 15, and the second being red. So because it is without replacement, all right. Obviously, when a student is picked, he will not pick the hat again. Already one has been taken out, right? So it's 7 over 15 times 6 over 14, okay? Plus 6 over 15 times 5 over 14 plus 2 over 15 times 1 over 14, right? So you will solve them, and that will be equal to 37 over 105. Any questions, please ask. Now, three students are picked at random. Find the probability that at least two of these three students wear red hat. At least two. Can we also use elimination here? 4-mark question. At least two. That means maybe we can do 1 minus probability of just one being red or no being red. Either one red or no red. Okay. That will eliminate the possibility of, or maybe first we can try the normally, okay, then we can try the other method. Okay, at least two. So that means first being red, second being red, and third being any color, right? Any other color, or let's say green slash white. Okay, we can write like that. This is one case, and the other case is at least two. So we consider two. Now consider all three are red. Okay. I think we don't need to use the previous one, 1 minus that elimination. This time this is shorter. So it depends in the question what method you can use, which will be shorter. No other possibility, right? Either two are red, 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 green, or all are red. Okay, red, red, green, white, or all are red. Now, obviously, the order can change here. Okay, this has two other versions. It can also be red, green, white, red, or it can also be green, white, and then red, red. So there are three possibilities, right? That's why we should multiply this with 3. All right, because 3 order matters. Order can change 3 times. So we'll just calculate one probability and multiply with 3. All right, so let's start solving it now. First being red, 7 over 15. Second being red, 6 over 14. And third being green or white, you can add green and white. 6 plus 2, 8. So 8 over, and how many are left now? 13. Because 2 already subtracted. This probability we need to multiply by 3, and then or means plus always. Remember, and means multiply, or mean plus, okay? And probability of red, 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 it's just 7 over 15 times 6 over 14 times 5 over 13. We just subtract 1 from each, okay? Please find the answer now. What will be the answer? Yes, anyone got the answer? Please tell me after solving these all. 20 seconds. Okay, so the answer is 29 over 65. Any questions? Please ask. Okay, let's do the tree diagram, important one. I think it's the first one we are doing now. The probability that Shalini is late for the school or any day is 1 by 6. Okay, so we can simply put 1 by 6 in the late, and any branch always add up to 1. So this is 1 minus 1 by 6, 5 by 6. All right, and the probability remains the same, so you can continue for the next one also. 1 by 6, 5 by 6, 1 by 6, 5 by 6. All right, easy. Calculate the probability that Shani is late on Monday but not late on Tuesday. Late on Monday, not late on Tuesday. So this is the branch that we need to follow the path. So that is 1 by 6 multiplied by 5 by 6. Whenever you are following the same branch, you need to multiply the probabilities. Okay. And when you will follow different branches, you need to add the probability. Okay. So that is 5 over 36. Any questions? Yeah, that's it for that question. Okay. We can move to the next. When you plant some seeds, the probability that a seed will produce a flower is 0.8. Okay. Probability of flower is 0.8. When a seed produces a flower, the seed when produces a flower and is red, flower is red, is 0.6. and that the flower is yellow. So like probability of flower being yellow is 0.3. Anya has a seed that produces flower. Okay. Find the probability that the flowers are not red or yellow. So that is 1 minus 0.6 and 0.3. Okay. 1 minus 0.6 plus 0.3. All right. So that is 0.1. Got it? Next, we need to complete the diagram. Change the color. Okay, first of all, producing flowers, not producing flower, obviously 0.2, 1 minus 0.8. Then the flower being red is 0.6, yellow 0.3, and other color 0.1. Got it? Same as before. Find the probability that a seed chosen at random produces red flowers. Okay, so definitely we just need to go to this path. Okay, 0.8 multiplied by 0.6, 0.48. Any questions? Next class is Monday. Okay, oh sorry, Thursday, because we did this week Wednesday, Thursday, Friday. Okay. Tanya chooses a seed at random to find the probability that this seed does not produce red flower and does not produce yellow flower. Okay, but it doesn't say that it produces any flowers. So that means we can either consider a seed, sorry, flower. There is a flower and it's not red or yellow. Not red or yellow. Or we can say no flower. Okay, because no flower will also be considered. This is a little trick, I think. Does not produce yellow flower. That might mean does no flower at all, right? It might be a trick. So let's try to do both cases. First one is let's restart the meeting then, because it will end in the middle of the question. Okay. Those not joining, please practice the worksheet. It has been shared in the group already. Okay. Because we'll start a new topic next week.